My talk's going to be about storm surges, what they are, why you should worry about them, and why if you're living in the city, should you care what something is happening out at sea that really, shouldn't really impact on you. So we all know about the tide. The tide is just the water sloshing in and out, moves up and down, really regular, really predictable, based on the movement of the planets and the moon. So just like astrology, only you can trust it, so it's sort of quite nice. So that's easy to understand. We can predict the tide any period. You just sum up lots of different harmonics and you get a nice predictable answer. So you've got the moon M2, so you get 2 tides a day, these diurnal constituents, 1 tide a day, and you can just sum all these up and you get to predict the tide that's going to happen at your coast. So it doesn't just slosh in and out though. What you actually get is this tidal wave moving around the basin. So you can get some points, these amphidromic points, where there's no tidal movement at all, and you get some larger ranges moving out. So we can predict that. We can sort of say what's going to happen in Liverpool. It's going to be very different. We can also measure it. So there's tidal gauges. The nearest one is just up the road in Bootle at the Gladstone dock. And this tidal gauge network was set up in '53 after violent storms in the North Sea and caused lots of flooding down in the Thames. So we've got this tide gauge network all around the UK, sites everywhere. It's not just in the UK, obviously. This is just like little locally centric, but they're measured all around the world. And you've got these recording facilities recording these astronomical tidal levels. But also on top of that, you get a storm surge. So the predictable part, easy, that's the blue one. But on top of that, you get the atmospheric meteorological effects. So high winds and low pressures can sort of slosh around and bring up this tidal level. So if you take away from this full total surge, you get a total level. You take away the astronomical tide and you get a surge. And this surge is particularly worrying in an area of low tidal range, like Venice, where you get quite a lot of flooding coming in, and they're used to it. They call it the agua alta, so it's high water during the wintertime, which comes in and floods St. Mark's Square. Now, positive surge is when you've got something above the regular tidal water. Negative surge, it's just low water. No one cares if the sea goes out. It's just can't get to your boat, but no one has a boat, so it's fine. Positive surges, you've really got to worry about because they're going to come in and cause some serious flooding at the coast. So a positive surge on top of an already high tide, you're going to start to get worried if you live along the coast here, or might get your car washed across the road. So you don't want to have that happening. So how can we predict what's on there? Unfortunately, the weather is a lot harder to predict, as you might have heard from Michael Fish back in the 80s when he said, don't worry, there's no hurricane coming, there's nothing to worry about. Well, it wasn't a hurricane, but it was a really big storm event, and that caused, as well as trees being knocked down and telegraph poles, it also caused some flooding. So what about Liverpool, closer to home? Are we at risk from coastal flooding? Liverpool's got a really high tidal range, so the regular astronomical stuff is quite big, it just sloshes up and down, 8-metre tidal range in the highest spring tide. But on top of that, you can get a surge of up to 2.5 metres. So maybe you should worry. And it's not just the water. Yeah, that'll come in, but it can also do some serious erosion at the coast. So if you've got a caravan in one of these beautiful summer parks, or if cliffs disappearing. So we have to worry about predicting the coast, and we can also predict, the state of the coast. So as well as predicting the tide every day, we can predict the sea state. So we can predict this surge. That's what happens at the National Oceanography Centre, so here's a plug for our website, and you can get these predictions for the next sort of, a couple of weeks in advance and predict what's going to happen at the sea state. You can also, if you're really worried about it like they are in Venice, you can shut it out. So they're building these enormous gates. So this Moses project is literally building a great tidal gate across the Adriatic Sea to keep out the 3-metre surge. Now that's quite an expensive solution. What's happening more locally is we're just sort of monitoring it. So there's these flood risk maps. This is just the Sefton Coast up towards Formby. And you can see these extents of where there's likely to be some flooding, sort of where's most at risk. And you can sort of just keep an eye on it for the time being. There's also, you can predict what's going to happen at the coast. So this is just 2 maps from '98 and 2007. And you can see that the red line is where they thought the coast was going to drop away. And they've done a pretty good job at it. But it's harder to predict because you've got to know what the rock and what the cliffs are made of. But you can, the frequency of the storms is also quite difficult to predict, and it's going to be going up. So there's this number of storms on the rise, and it's likely to increase under climate change. But how can you predict the storminess if we can't even predict when one storm is going to come? So they do lots and lots of runs, and they make this sort of border of predictability. So they know the temperature is going to go up, and that's the one on the left. But on the right is like a measure of storminess. So how many storms can we predict between now and 2080? And as you can see, there's quite a lot of uncertainty. Some predictions think it's going to go down. So is there any hope? Are we all just going to get washed away? But unfortunately, I'm going to run out of time, so I'm going to have to do that at the next talk. So I'll leave it there. Thank you.